Welcome IESA, Indian Electronics and Semiconductor Association. We are a premier industry body, and we work very closely with the industry and the government. And we help the industry in many ways. We play a key role in creating the talent pool. IESA works very closely with the Indian government, creating the studies for the industry, and also working with the government for creating policies and kind of implementing them, and then hosting these kind of things like webinars, and also we have premier events like Vision Summit, things like that. And so we created various special interest groups, and semiconductor manufacturing, focusing on both fabs and OSATs, is one of the special interest groups. And I am the chairman for the group. And we wanted to have a series of webinars focusing on the semiconductor manufacturing, and this is one of them. And as you know, semiconductor manufacturing needs a good infrastructure like clean rooms, clean water, clean air, and electricity. So there are many things needed, many kinds of infrastructure, facilities needed to make a fab happen in India. We already have a few fabs running in India, but Indian government created a semiconductor mission to take it to the commercial level, and both in terms of manufacturing as well as fabless semiconductor product companies. As most of you know, Indian government has created this semiconductor mission with a budget of $10 billion to promote both manufacturing and product companies. So with that in the background, we wanted to host a series of webinars and also create special sessions focusing on manufacturing during Vision Summit. And recently we had a VLSI conference. Even in that, we had a special session focusing on this. And with that, I like to introduce our speaker today, Mr. Jayadev ji. His full name is Mr. Jayadev Kenchappa, and he has a tremendous experience in this field, in the semiconductor manufacturing side, especially building clean rooms. Almost 47 years of professional track record, and he held various positions, including 34 years as the additional general manager at Bharat Electronics Limited. We know it as BEL. And he was the general manager for clean room technology at SRP Enviro Systems Private Limited, and also senior general manager for clean room technology and business development at Ashray Clean Room Presentations Private Limited. So he has provided consultancy services for clean rooms and utilities at several institutions, including IIT Guwahati, Kanpur, and Hyderabad, and Nano Manufacturing Technology Center in Bangalore. So Mr. Kenchappa has competency and achievements that include extensive experience and knowledge in clean room projects, such as making a layout for the clean room. How do we manage the air validation, HVAC, and utility facilities? So his specialization is really in designing, building, and validating clean rooms with a varying ISO classifications. So he is going to talk more about how they are classified and things like that. And Mr. Kenchappa also experience in marketing and business developments for clean rooms, as well as upgrading and troubleshooting existing clean room facilities. And he provides education, training, and workshops on clean room lab practice. So Jaydev's expertise and extensive experience in clean room projects have resulted in the successful completion of several projects in India, He is one of the subject matter experts, including strategic electronics, miniature transformers, and cardiac stent manufacturing, among others. So he was responsible for the upgrade and expansion of clean rooms for integrated circuits, circuit fabs, MEM labs, space grade HMCS, and super components during his time at Bharat Electronics. And Mr. Jayadev has a bachelor's degree in mechanical engineering from Mysore University and an MBA in production management from Bangalore University. So we are very lucky to, unfortunate to have Mr. Jayadev ji with us today to educate us how these clean rooms are designed, how they operate, how they work. And so with that, I hand it over to Mr. Jayadev ji to start his presentation. Thank you so much.
Thank you, Mr. Venkata, for introducing me. In this session, actually, we are planning to make it comfortable for the new entrants and the students who may not be full aware of what are clean rooms, why they are required, which makes the room contaminants, how to control the contaminants, and certain prototype layouts and air management is required for a clean room varies from ISO 5, that is class 100 to class 1 lakh ISO 8. Now I will start the presentation. So I will start with to understand what are the contaminants that make a room dirty. So this is a relative size of common airborne contaminants. We can categorize them into those particles which are visible to naked eye and invisible to naked eye. Apart from that, based on the sizes varying from macroparticle range, microparticle range, molecular macro range, molecular range, and ionic range. So let us understand what are visible contaminants and invisible contaminants. So the visible contaminants, which are visible to naked eye, up to 20 microns. Below 20 microns, they are invisible. So you can only see them through the optical microscope and scanning electron microscope. So visible to naked eye, you can easily remove them. But the invisible particles, we call it as invisible enemies for a semiconductor clean room or any clean room. Very difficult to control. So if you understand what are the contaminants, how they behave, how they enter into a room, easily you can control. So visible to naked eye is up to 20 microns. So for example, you can say sand, beach sand, maybe 1000 microns. Human hair is around 100 microns. They are visible. Below 20 microns, macroparticle range, maybe 10 microns, 1 micron, 0.1, 0.01, 0.001, varies from macroparticle range to ionic range. Simple example for macroparticle is a yeast cell. And pigment, carbon block, pyrogens, metal ions. So here, for the benefit of you, I'm comparing human hair with 100 micron, and a dust particle of 25 microns. In a clean room, we have to control 0.5 microns. Imagine the efforts in design, build, and validation to control 0.5 micron particles compared to 25 particles of a small dust particle and then human hair. to make you aware of human air, how much it can affect the clean room maintaining point. Then again, coming to these visible, invisible, these particles, basically you can categorize them into two particles. One is external and internal sources. The external source basically from biological vegetation of dry leaves, dead barks, pollens in the nature. Apart from that, the chemicals emanating from moving vehicles, heavy industries, mining, then building construction, carbon monoxide, CO2. All these materials will add from outside. Apart from that, the more dangerous is in an industrial application. Basically the process, the machineries, materials, utilities, and the people are the major source of contamination. Process, if we take the powder residuals, soldering operations, assembly, fittings, is largely burns. They are contamination. If we take machines, if it's not a clean compatible machine, corrosion may take place, wear and tear, physical deterioration. And if you see the process, a lot of chemicals, acids, alkalis, solvents, particularly airborne molecular contamination, that are normally using wet benches, it may caught in the recirculation of the air. That may have a lot of effect on vapors. And utilities like gas pipings, fittings, liquids, they are also source of contaminant. But more dangerous is people. Can't predict human behavior in a clean room. The hair, the skin, the clothing, transported particles, governing procedures, cleaning itself. Most of the times, instead of doing cleaning, we'll be adding contamination, reciprocating with the mop. We are pushing and pulling back the contaminants. For improper use of vacuum cleaner, they may add a lot of contaminations. So these are in general what are the sources of contamination. If you understand from where these contaminants are coming in, you can easily control them. Then let us understand what are the clean rooms. The first two lines is available in the website, a room in which it is filtered in order to keep impurities, etc., etc. A clean room is an environment typically used in manufacturing of or scientific research that has a low level of environmental pollutants such as dust, airborne microbes, aerosol particles, etc. But more accurately, a room has a controlled level of contamination that is specified by number of particles per cubic feet or cubic meter. In this sense, so many particles in 1 cubic feet and the size. That's all we define a clean room. But a clean room is better understood. It is a specially constructed and enclosed, environmentally controlled with air supply return pattern, control of static charges, and in certain requirements like control of vibration, noise, as required. And particularly with respect to airborne particulates, control of temperature, relative humidity, spatial pressure of the room, airflow methodologies, construction of materials used, operation maintenance protocol of the clean room. But as per ISO 146441, this definition is a room in which concentration of airborne particulates controlled and which is constructed and used in a manner to minimize the intrusion. Very important, minimize the intrusion, minimize the generation, and minimize the retention of particulates inside a room. Of course, apart from this, other relevant parameters like temperature, humidity, cleanliness level, pressure, viable organisms, and their control. This is the brief summary of what are clean rooms. Then why stringent and internal controls are required for a clean room? As you know already, the design complexities and the decrease in the line width increase in geometry below submicron level is going to nanoscale in the manufacture of integrated circuits. So there is a need of precision operations in the process required, which requires a special and stringent clean room environment. So nowadays, you can see now the speaker size is as low as 3 nanometers in the design. 65 nanometers chips are being fabricated. Apart from that, more important is the awareness of the quality. Because of the quality awareness, the requirement of clean room environment is becoming more and more necessity rather than demand. Once upon a time, it is a demand. Now it's become almost part and parcel of any manufacturing industry, particularly in semiconductors and some other segments of industries. Apart from that, there is an increased miniaturization of the products, advancement in microelectronics, and nano manufacturing, nanoscale characterization, micro machining, pharma, and biomedical technologies. All these three items mentioned above are basically what to do, why we are doing that. That is in order to reduce the defect densities. Thereby, there will be improvement in the yield of the product. That is the reason why all these stringent and special requirements are required for a clean room. Some three pictures that are discussed. See, future, you can see a microchip as small as that can insert into a small needle. Then electromechanicals, the magnified cog. This is a small wheel, should be as small as the head of an insect. And here a cardiac stent. So all these products require very stringent and controlled environment to manufacture. Then let us understand why clean rooms are required. So with the advent of quality awareness, as we discussed, across all segments of industries, particularly semiconductor packaging, OSAT, ATMP, and characterization, microelectromechanicals, nanoelectromechanicals, visible electronics, optics, photonics, LCD, LED, space technology, solar cells, medical electronics, automotive, precision manufacturing, pharmaceuticals, healthcare, and food industries. Now, more emphasis nowadays in our country is given for semiconductor packaging like OSAT and ATMP and their characterization. Because a lot of demand is there because of the shortage of chips and components required for automotive industry and other industries. There is a lot of need of semiconductor packaging industry in our country. Apart from that, to mention a few MEMS and flexible electronics. The MEMS, lot of sensors are being invented and being used. So the facility is required for manufacturing the sensors. And other thing is the flexible electron. This is gearing up like anything. Because these the electronic circuits and a flexible substrate plays very important role in OLEDs, displays, particularly for the army, where we use flexible electronics. The Jawans walking in the forest, they want to charge their walkie-talkie. Then solar cell embedded and flexible electronics will help in charging the batteries. Apart from this, flexible electronics useful in spacecrafts and different wherever there is a space constraint in a small space, you can do it in any flexible way. These displays can be introduced. Of course, more emphasis on solar cells and modules, medical electronics, particularly automotive like air braking, ABS systems, pharmaceutical, and pneumatics and radar components. Particularly, these are more important because these pneumatics and hydraulics are nothing but the volume. This is direction control valves, 2x2, 4x2. They move up and down the platform or move a lead frame for the die attach and wire bonding. So these hydraulic pneumatics also plays important role. And also they play major role in gas distribution system like toxic gases, particularly to use for automatic stopping the connection of toxic cylinder into the system. Okay. Now we'll move next to a good design of a control of a clean room will incorporate the following factors. One is pressurization, cleanliness, temperature, humidity, lighting, electrostatic discharge. In special cases, vibration may be required, noise control is required, acoustic is important, electromagnetic interference in controls. We'll discuss more on these pressurization, cleanliness level, temperature, humidity, lighting, and EST. What is the meaning of pressurization? Suppose you want to make a room clean. The first principle is keep the room at a positive pressure compared to the surroundings, so that ingress of contamination from outside into the room will be prevented. So you can see a picture here. See, this is indirectly you can call it as a meaningful migration of clean air from a clean room of most clean zones to the area of progressively less clean zones. For example, clean room A is the cleanest room. From that, it goes to the next bit diluted room, and go into the outside atmosphere as corridor. That's why pressure gradient, if we keep, we can avoid the ingress of contamination. The differential pressure between room to room, you may have to keep some 12.4 pascals, actually plus or minus 15 pascals only, normally you maintain, so that even though contamination generated, it migrates to the lesser clean rooms and go into the corridor. So based on this, pressure plays a very important role in maintaining the clean room. This is the first principle in which the clean rooms have been designed and built. So we will discuss the table, ISO how the table looks like this. This is ISO standard 146441. So normally I will just try to explain with reference to 0.5 microns. Very easy to explain this. See. So these 0.5 micron particles in 1 meter cube of air. Normally count a 0.5 micron particles in 1 cubic meter of air. We are referring to cubic meter. So if you see, you want ISO 3, there will be 35 particles of 0.5 micron in 1 cubic meter. That is equal to ISO 3. So you go normally we are more familiar with ISO 5. It is nothing but class 100. You see here federal standard 209E. Normally we talk in these terms because class 100, class 1000, 10,000 like easy to spell and understand. So class 100 is equivalent to ISO 5, which is equal to 3,520 particles of 0.5 micron in 1 cubic meter, which is equivalent to 100 particles in 1 cubic feet of air. Similarly, if you go for ISO 6, it's about 35,200 particles of 0.5 micron in 1 cubic meter of air in the room, which is equivalent to class 1,000 particles in 1 cubic feet of air. This is in general. This is a standard ISO. Most of us will follow these standards. So for benefit of those you are normally confused with the ISO 1 federal. I am giving a chart here, easy to understand. ISO 8 means 1 lakh particles. ISO 7 means 10,000 particles. ISO 6 means 1,000 particles. Like this, we can compare this to understand better. So I gave an example for ISO 7. So this is nothing but maximum available concentration of particles in 1 cubic meter of 0.5 micron and larger. 0.5 micron and larger particles shall be 3,52,500. Okay, but by doing validation, the concentration mentioned above are cumulative particles. That is, 3,52,000 particles at 0.5 micron includes the equivalent greater than 0.5. Apart from that 0.5, it includes 1 particle, 1 micron, 2 micron, 3 up to 5 microns for microparticle range. Up to 5 micron, whatever you get the reading up to 0.5 micron is recorded for validation purposes. So same thing if you see federal standard, it is equal to 10,000 particles, so 0.5 microns per cubic foot. So this concentration I already explained. So ISO 7, which is equal to class 10,000. So class of cleanliness, different class of cleanliness required for semiconductor manufacturing. This we were able to collect from different sources and users. Particularly the area of nanoprint litho, even the exterior laser lithography or deep ultraviolet lithography. The process are litho operations, coating and developing, line pattern, laser analyzer. Normally they go ISO 4. To go for photolithography like mask aligner, heaving lithography, double-sided mask aligner, mask writer, photoresist coating and developing with ISO 5 class 100. Then some furnace operations, etching process like diffusion, dye processes, DRI, RI, for all these processes, ISO 6. Then characterization and packaging, process may be ellipsometer, conductive meter, scanning electron microscope, transmission electron microscope, and packaging like OSAT can go for ISO 7. ISO 6 for characterization, sometimes them use ISO 6. This is normally practiced in the industry. So different environment required for the manufacturing in terms of the temperature, relative humidity, class of cleanliness, air change per hour, and velocity. The process like a nanoprinto, litho, here see the tolerance is plus or minus 0.5 degrees centigrade. Very difficult to achieve unless proper design is done, proper layout is done, it's difficult to achieve. And rate humidity is normally 43 to 3% to 3.5% plus or minus. ISO 4 is class 10 clean room. And very important is again photolithography. Its tolerance may be plus or minus 1 degree. RH 45 plus or minus 5. ISO 5. For these two, as per standard, you have to maintain the velocity 90 plus or minus 10 feet per minute. May vary sometimes 0.3 to 0.5 meters per second. Then we go to diffusion processes, where after photolithography you diffuse vapors in the furnace, making surface passivate. Passivate that you pass through the different furnaces and do different processes. Plus or minus 1 degree the temperature control. 45% is to 50% RH varies. ISO 6, that is class 1000 cleans are required. And air change per hour as per standard is varies from 70 to 160. And here velocity is not applicable. We go for packaging, other operations other than diffusion and photolithography can go even 21, 22 degrees, 2 degrees the tolerance. 50 to 55% is orange. Can go for ISO 7, ISO 8 means class 10,000 to class 1 lakh clean rooms. For ISO 7, 30 to 70 ACPH is recommended. And for ISO 8, 10 to 20 ACPH. Apart from that, let us discuss on the types of filters we are going to use, the airflow pattern, types of floor we use for the clean room. For photolitho, nanoprinto, probably this may be class 100 clean room. For class 100 clean room, normally we use HEPA filters H14, 99.9995% down to 0.3 micron particle. And for ISO 4, alpha filters, ultra low penetrating air filters, called U15, 99.9995% down to 0.12 microns. Here is 0.3 microns, 0.12 microns. And unidirectional. Normally people mistake what is unidirectional. The flow of the air is one direction, either top to bottom or one end to another end horizontal. So unidirectional flow is when the air flows from the ceiling ground to be perpendicular, lines to be perpendicular to the laminar flow. Normally we may achieve this by maintaining 90 plus or minus 20 feet per minute. So in the roof, the full roof will be covered with HEPA filters. Air flows down to the perforated red axis flooring and goes back to recirculation. And we have to properly adjust airflow pattern such that vertical laminar is achieved. So the types of floor, raised access perforated metallic tiles with ESD on the surface. So ESD in surface is more important. We 10 to the power of 5 to the power of 7 ohm centimeter. And these raised access floors, discuss later what is the quality, what type of material used. Next, we go to diffusion processes, dry process development, characterization, clean corridors. It can be some cases that normally we can use H14 filters. Direction may be some diffusion process, they need reduction flow. For other applications than diffusion and photolithography, use non-unidirectional or mixed flow. In photolitho and as well as the diffusion process, we use raised access perforated flooring. And in other cases, return here can be low wall return with PVC SB type. Low wall means supply comes from the bottom top. So all along the periphery of the wall, about 200 mm, 300 mm above the floor, return air goes back into the AHU through the return air risers. In some cases, the flooring may be with ESD tiles, 600, 600, again with ESD control of 10 to the power 5, 20 to the power 7 centimeter, ohm centimeter. For packaging and other applications, it is a mixed flow. So air comes from the bottom, from the top, and moves all along the wall like a piston flow, and then go back to the HO. And here we can use the PVC ESD tiles or sheets of 2 to 3 mm thick with ESD control. So these are the normal environments construction materials required. So more important is relative humidity. For semiconductor application is more important because that is a culprit. Typically, a set point of 45 to 50% is with a control bandwidth of 5% is satisfies both comfort conditions and the process requirement. In some cases, the tolerance will be customized 0.3 to 3.5%. But in the case of nano manufacturing and characterization labs, it requires stringent of 2%, 2 to 3% upon 45% humidity. One care you should take because if RH goes down 38%, lot of static charges will increase. It increases the contamination in the facility. So we should carefully control this. Should not go below 38, should not go above 55. So we have to use relatively, we have to use it. Sometimes we may have to use dehumidification units or humidification units. Dehumidification, what happens is when you take the outside air, up to certain can use using cooling coils. Apart from that, removing the moisture from the outside air by using dehumidifier, so that we can from 82% to 45% can reduce by using dehumidifier and also with heater. Suppose relative humidity goes down 40%, so we have to add some water vapor. That by using humidification, by adding water vapor. Clean room lighting, particularly for photolithography and diffusion operations, we have to use teardrop light fixtures. Having, if it is a yellow room, we can use 550 nanometers around that wavelength. Here important is why we use teardrop light fixtures. You can see in the picture, 100% ceiling is covered with HEPA filter. So if I put, I remove one HEPA filter and put light fixture at 2200 or 200 or 600, 600, like that 4 or 5 places, that zone becomes dead zone. So we can't achieve class 100. So what we have to do is we have to put teardrop light fixture in the ceiling which is 55 mm width. Please take here an example. So this is a 55 mm width. In that we are fixing a teardrop light fixture. So you can see here, it takes 3 times the width to become laminar. Airflow will be laminar. So if it's 55 mm to 3. So when it comes here, it becomes laminar. Suppose if you put 2 feet width, like fixture, 3 times is almost 6 feet. For a clean room height is 10 feet. So at the 6 feet, it becomes laminar. So what all effort you put here, without using clear rod fixtures, you can't get the laminar. Hence, clear rod fixtures is a very important role, whether it may be white or it may be yellow. Because yellow can mention about 550 nanometers, maybe around 4,500 degree Kelvin is the temperature, Kelvin temperature. Now we can classify the clean rooms based on standards, physical layout, air flow patterns, types of clean rooms we are using. We'll discuss more on these two items like air flow pattern, how it looks, types of clean room are going to use. So this is a class standard unidirectional flow. This is a picture. See, vertical air flows down to the graded flooring and recirculates. We call it as vertical laminar flow or unidirectional flow air. It goes directly parallel to the flow. So this can be achieved by using fan filter units. The picture. So this is a graded flooring, and this is a false ceiling. We have housed a number of FFUs, fan feed units or fan filter modules. So the major air required to control temperature and humidity will be sent into this between ceiling and the false ceiling. So that air is picked up by fan feed units and circulates for local return system. Advantage of this fan filter module is we can independently control the airflow volume depending upon your requirement. Suppose suddenly you want to convert this area into a bit, suppose it is class 10,000 or class 100, just cloud the ceiling with your number of FFUs. So by clouding this area becomes class 1000 or 100. There is an advantage of fan filter units. How it looks? This is a fan filter unit. And this is the photo taken at the site. And there is a pre-filter for this. And this is about 200, 275 mm depth, 600 and 1200 mm. Got a pre-filter. Inside the filter dimension is almost equal to this. Whereas the glass wool what you use, glass media, maybe about 58 to 60 mm thickness. So you can see the cloud of FF is used in a class 1000 clean room. This is actual picture taken at the site. So this is example of vertical laminar flow ISO 5 photolithography. You can see here Canada blade pictures. Yellow color, light, is graded flooring. More important thing is when you put DSME or photolitho process to isolate the whole tool area, other parts of the perforated flooring. So we have to make the foundation on the bottom and isolate it by giving 600 mm gap around so that no vibration is transferred to the tool. So this care should be taken within the initial stage of the design and the building itself. This ISO 5 photolithography. Another method is using non-unidirectional airflow. We are using FFU, but there is no graded flooring. We call it as a mixed flow. There comes like these circulations. Because there may be some constraints. There may not be available sufficient space for sinking the floor up to 600 mm or 900 mm. In that case, this becomes the base of the clean room floor. You can use ESD tiles, and air comes from the top and recirculation. Another method of achieving the ISO 6 clean room. How it looks. This we are supplying the required air for controlling temperature and humidity between false ceiling and the ceiling. The ceiling is also encapsulated like using some puff material. So air is sucked from this recirculates to the return riser and recirculates. So this is another method of constructing the clean room. This is the resultant of ISO 6 using mixed flow. Air comes from the filters and go all along the return path and goes back and comes back. You can see all along the return air path. We've got a grills here. with a written risers to control temperature, control humidity. This written air is more important. Some part of the air from the room is taken back to the AHU to control temperature and RH. So this is a picture of another method is using airflow diagram using hooded HEPA. This is for unidirectional, not unidirectional, because it is only for mixed flow. Sometimes we can use unidirectional also using downward flow with raised axis. But here instead of FFU, you will have HEPA filters. So you can see the supply duct, return duct coming from that. Here what we are fixing is this hooded HEPA. This is about 300 mm depth, same size, and there is a round collar to the flexible duct and a filter fixed inside this. This is another method of achieving using hooded HEPA filters. How we connect from the supply duct to a flexible duct to the hooded HEPA. It looks like this in the cleaner. And the resultant of is plus 100 clean room with Piada plate fixtures with perforated flooring and all. Particularly in this case, we have to use the particularly for class 100. To use class 100 compatible wall panel, ceiling, flooring, and all other materials required. Another method is the mixed flow. So here again we can use the hooded HEPA filters and return air from the all the two sides or four sides. So recirculates like this. We call it the mixed flow, a bit vertical and then mix. Take the directions of the mixed flow, vertical as well as horizontal. We call it the mixed flow. And resultant for mixed flow, this may be more suitable for OSAT assembly packaging. ISO 7 clean room with a mixed flow using, you can see the hooded HEPA in the ceiling, light fixtures, and return air possibly all along the wall. And you can see the clean corridor itself, how clean it looks. ISO 8 is class 1 lakh corridor. This is a picture taken from a facility recently we built. So another method is hybrid. Mostly people may not use it, but suppose in a big clean room, we want to make only a small portion as ISO 5 or ISO 6 in ISO 7 clean room. You can use perforated flooring in this portion where you need ISO 6, ISO 7 clean room, vertical laminar flow, and balance can be return air can be taken back to this case, return like this, vertical as well as. See how it looks. This looks like this. So from the ceiling, vertical air can go here wherever required, and return also go all along the low volume, low level of the wall. This is another type of gel-filled ceiling grid. Most of the people may not be using this. Very rarely we use. But this is another important thing is where there is a confinement, there space problem is there here. And this is a top portion of the chamber, and here is the HEPA filters fixed in this. Okay? And this is a pressurized chamber. So we supply pressurized air here, and more care you have to take so that pressurized air should not leak through the joints. So for that, you can use for IS5. So for this, we use gel-filled grid with knife edge. You can see this is the grid. This is grid fixed to the ceiling, and you can see here gel is filled in this. And then these are filter. These are also filter. The knife edge is inserted into this, so it's sealed pakka, so that there is no air flows to the room. Even though it's pressurized, it will come through only the HEPA filters. So this is another thing. Like internal finishes. Okay. Internal finishes must be, that is, whatever you encapsulate inside the room should be non-shedding, non-porous, surfaces be smooth and easy to clean, minimal joints and ledges should be there, without corners that are difficult to access, free from accumulation and generation of dust, able to withstand repeated cleaning and resistant to microbial growth. These are important requirements of the wall ceiling, the flooring, the wall panel. Here, the total thickness of the wall panel, puff panel, basically explaining the puff panel. varies from 58 to 100 mm thick, depending upon different sizes. The core material used inside in this will be puff material or EPS or rock wool. And it have outer and inner surfaces with 0.5 mm thick powder coated. EPSP means galvanoplane single pass steel you have to use. Properly select the steel before fabricating wall panels. It may be SS also. So the three types of materials you can use is J powder coated copper EPS, J powder coated rock wool as infill material, some optional cases, and stainless steel with EPS or copper material, infill material, depending upon. So this is how it looks. This is a coving which makes the radius between ceiling and the wall. This is from floor to wall panel. I can see a view panel. This is how bottom and top risers are there. So advantage of this coving is more important, easy to clean, and there is no accumulation of dust particles in the corners. This is concave and this is a convex top. But for internal finishes for ISO 5, class 100 clean room, it requires a special material. Okay? Metallic wall and ceiling system, special material for ISO 5 and better is aluminum honeycomb paneling with surface anti-static finish. So anti-static finish is more important. Even from the wall panel, you can not expect the contaminants in static charges. So use surface finish of the wall panel, ceiling panel will be anti-static. Apart from that, we have zero outgassing rate. Zero outgassing rate means number of particles in microton liter per second per centimeter square. In the sense, so many micrograms of particles in 1 centimeter square surface of the area in 1 second should as less as possible. Normally, we have to go for a zero out gas price of 5 plus 100. Then these panels will be sealantless. Suppose if it is sealant, no, over a period it may that is a contamination. So class 100 requires sealantless and studless. There is no fastenings. Fastenings also may rust or it may also break away. So better specification of a class 100 clean room is aluminum honeycomb panel with anti-static finish, outgas rate 0, with sealantless and studless. And it's demountable means suppose I want to move equipment, easily remove it and put the equipment inside. Apart from that, if you go for a photolithography, UV filtered film should be pasted on the glazed surfaces wherever, like the door entry where you view panels. But use that. Then for special application like GRP, gas reinforced plastic, non-metallic special application like atomic and energy and research. These are the different types of materials used for different applications. This is an example of ISO 5 aluminum honeycomb. So this is two pieces. We can join here with top track and bottom track. So this is, you can see here in the horizontal bar, is aluminum honeycomb. And their foil will be 0 mm thickness. And the diameter of aluminum honeycomb may be 10 to 20 mm diameter. It requires a special false sealing. So perfect alignment should be there for with self leveling systems. So available in powder coated and heat and light engineering. Sealant free and issue demountable type for ISO 5 and better. And should be able to incorporate lighting, sprinkler head, HEPA filters, ceiling panels, and other accessories. So they should be flexible, turn method adjust the height, and it should be usable 100% after some time. So this is the T grid type used for a class ISO 6 and ISO 5 and 4. It is a reverse T grid, and you can see the aluminum extruded material. And you can see in the bottom 55 mm, to which you can put the teardrop fixtures. This will accommodate filters 1200 to 600 mm, filter per filter or ready for or even effectives. Coming to the floors. So concrete will be used as a common floor for foundation for almost all the clean rooms. A smooth, impervious, and durable surface would be then added. This should be resistant to spill chemicals and slip resistant. Most precaution you will take during construction is vacuum degas flooring is more important. Remove the moisture from the concrete flooring. So in hurry now, most of the projects, our experience is that people have a shortage of time. They say finish the clean room fast. So if the contractor will not degas moisture content for a period of 1 year or 2 years, you can see moisture coming up if it is PVC falling, comes up and breaks the joints, and then moisture will enter into the room, and we are not able to control the. It's common to use materials have effective electrostatic dissipative type minimum outgassing properties for semiconductor manufacture. Vinyl flooring either PVC sheets or tiles with 10 to the power 5 to 10 to the power 7 ohm centimeter. Resistivity is required. For unidirectional flow, vertical laminar flow, aluminum raised perforated or graded flooring is required with edge surface. Vinyl flooring, either sheets or tiles, may also be used. Epoxy flooring, in some cases where chemicals are there. Of course, with ESD, epoxy also available. So this is how a perforated grade tile looks. It's 600 by 600. This is 44 mm die-cast aluminum. It uses pedestals for pedestal. So if you see this actual picture we are taken from side, from the top, if you see it looks like this. From the back side it looks like this. So in the back side we have accessories. You can control the volume. You can increase or decrease the volume. The quantity of air flowing through the tiles can be controlled. So they are die-cast materials with 44 mm thick with ESD surface on the surface. Here they should be capable of taking the load of the process tools. Okay. So in this case, they will take ultimate distributed load of 100 to 150 kg force. Concentrated is 500 to 500 kg force. Ultimate load, this center of the tile can take 1250 kg. So that any process tool can be based on these tiles and will take the load. This is the specification. So coming to an example for, suppose you want to set up ATM or set facility, the following parameters are important. For example, ISO 7 is normally specified for ATM and OSAT. Control of temperature important, humidity, class of cleanliness, facial pressure, lighting is important. Module internal fabrics as we discussed. Similarly, ceiling grid and panels, doors and windows, glass vision panels, covings, rigid flooring and clean room accessories. These are the important parameters and accessories required for doing the process of ATMP and some conceptual representative layouts I like to project. So this is a representative view. So we have here layout. This is clean out 5,000 square feet, around 5,000, 5,000, 5,000, 3 clean rooms. And this is the people will enter here, and then changing room. The people enter through this way, this corridor. This corridor is clean corridor, and through this they can enter through changing room. And surrounding this, you can see here, they are all utility corridors where all pipings, electrical can run all around and then hook into the equipments. Adjacent to this are utility building or utility corridor where you can AHUs, individual AHUs for each clean room. And these are chillers place. Here it may be for chemical storage, ETP, ATP. Then this is for transformers and electrical system. For the entry, this is only conceptual view. Another layout will look like this. So here a number of clusters. You can see here this is the utility corridor. Between each clean room, we have utility corridor. and people enter through this rental corridor. Enter this is a utility building where you can house all HUs, and put the fillers, and DI water, compressed air. Advantage in this is again a utility corridor. We can go all round piping, then enter through this stage and connect to equipments. So the people entering for maintenance are not necessary to enter into the clean room. Thereby, the contamination is diluted or reduced by separating the clean room from the utility case. This is another small layout for concept for using nanofabs. Nowadays, nanofabs are coming. We call it the clean way and spine. One important thing here is these are all the white portion of Java clean rooms. Maybe class 100, class 10, class 1000. So 6 modules you can see. One important thing is we have designed a separate final type of utility corridor. Whatever utility corridor, you take all the utilities all along this. So you can see we are shrinking the clean room to minimum possible area and increasing to some extent. Utility corridor runs in the center. So we can, whatever you want, electrical, compressed dry air, day water, all can be done in the center and connect to both the clean rooms. So here, the maintenance people or utility corridor can come here and go back. The clean room people can go here and do process. They are in a clean corridor like this, and this is the dirty corridor, called as a gray chase, and this is the clean bay. This concept advantage is called like a spinal cord. No? All along the spinal cord, we connect whatever we like. Otherwise, what happens? Suppose I want to do in a conventional way. I run all clean room in the center, this is central corridor, and we can connect to this. But utility run all along. So the length of the pipes, pressure drops, cost can also be reduced. So this is a concept which we are working out, and one of the areas we are able to do this. And this is a small lab for a college. You can see here, small lab with photolithography about 150 square feet using 100% of coverage. And this is a lab, ISO 7. You can do a lot of process here. And here what we can do it is, suppose some equipment, the only important portion you can put into the clean room, thereby reduce the clean room area. And unimportant part of the equipment you can put into the case area. This is dotted area is case area. So our concept should shrink the clean rooms so that the area become less, number of people working less, and we can properly maintain the clean room. And this type of arrangement, putting the equipment, we call it as bulk edit type tools. So let us discuss on visual requirement of semiconductor fabrication facility. Nowadays, a lot of thinking is going on. Country like we want to see a big fab. So to construct a fab, what are the things required? I just listed it out. Basically, clean room fabrics, modular wall panel, ceiling grid and panels, doors and window vision panels, covings, raised access floor with ESD vinyl tiles, air ionizer. This also plays important. Most of our people may not be using ionizers because whenever air is recirculating, it gets charged. A lot of contaminated charged particles in the air. You put air ionizers also, it removes the charged particles. Then clean room lighting is more important. Commissioning validation is important. HVAC is important, like chillers, chilled water distribution, pressurizing units for chilled water, dry cooling coils. Dry cooling coils for the water system, dehumidification system, recirculation air handling unit, fresh air and makeup air distribution system, filtration like HEPA filters, alpha filters, etc. So these clean room fabrics varies. Suppose you want class 100, as we discussed, go for aluminum honeycomb with outgassing rate 0. And what are the properties we discussed? Clean room lighting again, it depends upon photolithography. Sometimes photolithography, whatever photoresist you use, that dictates the wavelength in terms of nanometers. It may be depending upon positive photoresist or negative photoresist. We can go for the types of color of the light, whether amber or go for yellow color with 50 nanometers to 40 nanometers. And then HVAC, the chiller plays important role to control temperature, so supplying chilled water to the aeronatic system. And humidification is more important in the case of clean rooms for semiconductors. So here what happens is outside here, for example, if you take in Bangalore conditions, outside important thing is to consider the monsoon. Monsoon about 82% RH will be there. Okay. So this 82% RH, you want to reduce to 45% RH. So whatever I have to 82% RH is there in outside air. See, this outside air contains around 145 to 150 grains per pound. That air has to be pre-cooled, removed of moisture content, and then sent into the dehumidifier, where dehumidifier further reduces moisture content, supply into the recirculation unit, the required grains per pound of air that is conducive to use for the. Similarly, humidification also plays important. If it goes below 38% RH, a lot of static charges will be more. So we have to use a fan type humidifier, which sprays the water vapor when it goes 38 RH. Makeup air also makes very important because normally what happens, makeup air is calculated based on what is process exhaust taking out of the process tool. Most of the people very difficult because are more important. Normally, if that dictates the waveback, because when you are exhausting say 5,000 CFM air, I have to compensate 5,000 CFM air from outside air. Apart from that, there may be some number of doors to which, because room is pressurized, a lot of exfiltration takes place. So the process exhaust plus exfiltration together, but calculate the pressure and should make it properly for treated pressure supply to the room. Then air distribution we discussed, vertical laminar, unidirectional flow, mixed flow, and then hybrid flow of different types. Particularly filtration plays there, heart of clean room. Ultra high efficiency particulate filter, ultra low penetrating air filters, and fan filter module systems. So these deposit efficiency also plays more important to 99.995% down to 0.2 microns. Alpha filters 99.995 up to 0.1 microns. These are the HVAC for clean room. Further, the list is very big. I just run through. The clean room accessories are required are air showers, garment storage, transfer hatch, step over bench, auto shoe cover, clean room shoe cover, cleaner, governing mirror, eye wash, clean room chairs, 316 stainless steel, wet bench, laminar flow stations, step over benches, vapor storage cabinets, vacuum wands, autoclave, clean room laundry, particle counter, and vacuum cleaner. Normally, here more emphasis is given on clean room laundry. Most of the people, I don't know how we are doing, we have independent, we have laundry with our own facilities, more important. And this laundry should be kept under a class 1000 or a class 7 clean room, so that whatever you do, process of cleaning should be under this. Otherwise, give to outside what clean that fellow, you can take it and tie it in the outside. It has a lot of contamination, and then you put iron on that. Again, it diffuses. The moment I can open the chlorine inside the room, that's contamination. So having clean room laundry is more important for semiconductor fabs. And then vacuum cleaners also important here, because vacuum cleaners should be dedicated to each room, should not take it out. And also how the vacuum cleaner itself is a clean surfaces, flexible ducts connecting to remove particles, also important. So otherwise you can go for house vacuum. You can put a vacuum cleaner outside and flexible ducts can collect the particles. Utilities like process cooling water, town water, ultra pure water, compressed air, house vacuum, process exhaust systems, wet scrubbers, dry scrubbers, process effluent treatment plant, STP, process gas used to be like bulk, toxic, flammable, pyrophoric, corrosive, inert, then containment supports, BMS controls, public address systems, local area network, telephone, personal assistant alarm, fire detection and suppression. Therefore, semiconductors normally recommend the FM200 air suppression system rather than going for the water spray. Because the water spray, if you use, what happens? A lot of costly equipment, they may get damaged, and also a lot of process wafers may get damaged. So go for gas suppression system, gas detection system, then emergency showers, access control, ECT. Apart from that, toxic chemical storage disposal, gas cylinder and storage, pipes and bridges, cable and trays, supporting structures of the utilities. They are like a switch gear, process power distribution, other electricals, water controls, UPS system, DG set, electrical grounding, VFDs, EMI shield and vibration. These last two are more important for when you go down to nano scale. The EM also plays important role in controlling some of the process of nanoscale. Vibration is also important because it may, the vibration, what it can do in particularly nanoscale characterization, any drift because of vibration of the sample will not give a proper result. So the air velocity, the flowing in the characterization is also important. So these are the important requirements of a nanofab. So this is how a fab can look. This is a fab and there utility building. All around a cluster of utilities are required. These are utility for gases and liquids. This I'm not elaborating much because it takes a lot of time. Now this is how a control zones can be generated for fabs. This is a basic concept. See, this is called service corridor, called the gray area concept. And these are the clean bay concept. So each will have its own process. This is another method of clean room. Suppose this, say I make a class 100. So the adjacent areas may be class 1000. Okay. And here what happens in class 10? We can put only the loading portion of the equipment and balance portion can be outside. So like this, you can make different types of layouts. This is another way. So if you have a conceptual or dream semiconductor fab, it may look like this. So you can see here people entering through this and then going into the clean rooms through this entry corridor, and each bay will be there. And this is all, this is basically the utility corridors. You can each clean room have its own bay, and then this is visitor corridor. So this is our dream semiconductor fab to be required, and around that utilities may look like this. So this is the fab, and this is the characterization. They may be, these are all the chiller systems. These are utility systems. So further applications of the clean rooms are maybe in application of thin films, powders, basically nano applications in metal, a lot of the metal development is going on. That these are the things. Further, we have clean rooms for thin films, protective films, nano emulsion powders, smart materials, a lot of R&D going on this. They also require a lot of clean rooms. Further, for example, solar energy, optics, chemical technology, aviation space, biotechnology, automotive, building construction, aeronautics. So these are the futuristic clean room requirement. So application of clean room may be from computer parts, human parts. Apart from that, medical shots to shots. So this is what I wanted to dissipate or collected information sharing with the people. Thank you.
Thank you so much, Mr. Jayadev, sir. It was a thoroughly enlightening and very clear and concise presentation. And the diagrams were very well detailed and self-explanatory. Thank you so much. With your permission, sir, can we spend maybe about 15 minutes until 2 o'clock for question and answers?
Yeah.
We've got some questions on the question box. I'll just take them in the order we've come. Maybe we won't spend, too much time on, there's about maybe 10 questions, so maybe we can try to spend 30 seconds or 1 minute on the answers each if possible so we can get all of them. And the first question is from Shubi Tandon. Sir, is electrostatic charge energy considered a contaminant?
Electric charge is not contaminant. It generates particles because
Only
of the
particles.
Yeah.
From Meghana Gorantla, from Srinivas Jagadisan, how often do we need to change the filters for maintaining the class?
Okay, suppose HEPA filters normally is well maintained, operation maintenance protocol and then clean room protocols are followed. Maybe not less than 5 years.
5 years for HEPA
Yeah.
filter, sure. And obviously, depending on how dirty it is, you have to
How you
service.
maintain it, called maintenance
You maintain
protocols.
it. From Vishal Saharavat, is there an option to clean the filter or just changing it?
No, HEPA filters you can't use and throw. Can't use them. HEPA filters
Use and throw?
Yeah, use and throw.
From Dinesh, if we are not going with raised floor, can we
Yeah.
go with regular flooring with ESD tiles, and how the connectivity from room to room?
Okay. See, normally not necessarily go always rated flooring. If it's ISO 5 or ISO 6, some people require this. For ISO 5, definitely rated flooring is required. Otherwise, you can't validate it as a clean room. There is a flat surface and you cannot call it as a clean ISO 5. It's with rated flooring. Non-ISO 5 clean rooms, you can go for flooring with the tiles or there may be some sheets are there with ESP control from room to room. You can spread it and on that you can put the wall and ceiling panels. Return air will be through the retainer risers all along the wall.
Thank you,
Answer?
sir. From Srinivas Jagadishan again, is there any time constraint on window opening and closing for material transfer between clean room and the outside?
Repeat the question.
Is there any time constraint on window opening and closing? I think he doesn't mean windows. I think he means shutters or for movement of material from the outside.
So movement of the materials you can have that. There will be special boxes.
I think you answered that question in your presentation. There's different rooms of different cleanliness, and you progressively reach the clean room. So it'll go into isolation
There
chambers.
will be pass boxes. Between rooms you can put the pass boxes. People need not enter. So in the pass box, one door is closed, another door is opened.
Yeah.
So you put your product there, transfer the material. One door is open. When you close, other door will open. So it will not add any contamination. And also in the pass boxes, there will be dynamic pass box where there is a mini plate of HEPA filters will be there. It cleans while storing also.
And the fans also, I think, from passage to passage.
Yeah.
Again, from Srinivas Jagadishan, he's quite enthusiastic. What fire extinguisher method is used in clean rooms?
So fire extinguisher is only suppression, fire suppression, gas suppression system. FM 200 gas is used because it is harmless. It will not damage like water. When the water falls on the costly products, and also the tools, it damages because each product cost may be 400, 500 crores worth wafers may be there. And equipment are also very costly process. So that go for FM 200 gas suppression system instead of water sprinkler.
Very clear, sir. Thank you. Then a question from Dr. Anil Kumar. What will be the complexity of integrated circuits fabricated in clean room in the model shown for educational institutions and the approximate cost?
Cost is very difficult depending upon the area. The education institutions, okay, that maybe 150 to 200 square feet area is required. For educational institutions, you need not go vertical rated flooring. For R&D purposes, you can keep one mass collider, one microscope, a small wet bench, okay, and some diffusion area, small area. Okay. For that manufacturing, ISO 6 maybe about 10,000 rupees per square feet. ISO 5 at check and come back.
And the approximate cost, sir, for an educational institution?
For ISO 6, if they go, maybe about 8 to 10,000 rupees per square feet.
8 to 10,000 rupees square foot and approximately 10,000 square feet of built up area.
Not necessarily 5,000 sufficient.
5,000 is sufficient for an institution. Of course, we have already some clean rooms at many of our prestigious educational institutions already today operating beautifully.
Yeah.
Question from Shubhi Tandon. What equipments are required to validate a clean room for semiconductors? How do you validate the clean room?
So validation will be done. First, we have to check the velocity of the air flowing. The meters will be there. It checks the velocity. Based on the velocity, You can multiply that into Q, that is Q is equal to VA formula. So when you know what is the velocity, you know the area of the filter, you can calculate the quantity of air coming at the same time velocity. Second thing is the particle counts. The particle counts are there as per some standard method. To select the number of samples and then collect what is it. Apart from that, there's some smoke test will be there to see how the air flows directionally. Then there will be pressure gauges to check what is the pressure inside outside the room. And there will be light to intensity measuring things. And so many. And also hood is required to measure velocity also.
Also humidity sensors, temperature sensors, all of those, we data log those.
That's actually on the digital will be there in the rooms, but actually use spin thermometer to give accurate temperature and humidity. With that, they will measure.
Sure, sir. Thank you. Next question from Nilesh Ranpura. For Semicon Fab, which type of ISO clean room is needed at 28 nanometers? And what will be the construction / setup time for this?
Okay. Right now, I don't know. For 28 nanometers, definitely we are not able to even do 61 nanometers. As in today, maybe to go for 20 nanometers, go to ISO 4 using standard mechanical interfacing with automated guided vehicles with intelligent enclosures and environment chambers. Okay, a lot has to go in that. And also the whole building should be isolated. Other parts of the earth, they're making a trench. And then should have subwoofer fab and supply air system, return air system. And better to have small clean rooms instead of making a bulk part. Because a lot of contamination is added if you make more and more area. So like bulk-headed type of tools should be procured and then you can procure. Time frame, I don't know. The building, if you start from the day building is designed by architecture, from the day given okay for the drawing to construct, it may take 2 to 3 years minimum. 2 years. Apart from that, land acquirement and then our design, using the design, and particularly nowadays.
Oh, is it audible?
So I guess Jayadev sir is on mute.
Sir, you're not audible, sir? Maybe by... You're audible again.
Okay.
Yeah, so we lost you. Approximate time, you said 2 years.
Yeah.
Depending on land availability, and then we lost you.
Yeah, that's all.
That's all. I think in the recent ecosystem seminar we attended, they were saying 2 to 3 years is highly ambitious for the India fab.
For construction, okay. Now to procure the land,
Yeah.
it takes 1 to 1.5 years.
We all know.
If you go from the day one, you can have proper project management team. If you have the time, approved drawing is there, 2 years to build. Validation say another 1 month. Then you push the equipment. Parallel activities, certain CPM chart if you make it more useful.
And long lead times on the equipment nowadays.
Yes, it may take 1 year.
Exactly. Sir, the next question is regarding power. How would power outage impact the concept of clean rooms? What procedures are in place to maintain clean room conditions during semiconductor manufacturing in the event of power outage?
The power outage, you have alternatives. For example, you have supply from the mains. Okay, we have DG sets, diesel generators that you would have, UPS you would have, and particularly some important equipments. Also, the equipments you would have your own separate UPS system or DG sets for that. Okay. So for lighting are selected, you can have UPS.
Sure.
And sometimes you can harness the solar for normal applications.
Sure.
But actually, if you speak, the power required for utilities is more than the process. 2/3. The area occupied for process tool is 1, 2.5 times space is required for utilities. In terms of area.
Utilities,
Power also is like that.
the panel board, the UPS, the batteries,
Yeah, for running the utilities, for example,
HVAC,
water, air juice,
water,
gas,
RO.
water, day water, compress the air, vacuum system. What I discussed in
Nitrogen.
several points, no? So power is almost 2 times the production.
Sure. There's a question not really related to clean rooms from Ritika. Maybe I can answer it, but how many layers PCB can be manufactured? See, that doesn't depend on the clean rooms as much as the equipment and the technology. PCB layers. Oh, maybe I can rephrase the question. Are there different clean room standards based on the number of layers of the PCB, for example, in an EMS clean room?
See, normally for PCBs, we recommend ISO 7, the class 10,000 clean room. Wherever layoff you do and some pattern you're copying, in yellow room, that may be ISO 6, class 1000 is required. A small room it is.
Sure. And it doesn't matter the number of layers. There's no criteria as such.
There's no criteria.
It'll be whether it's 2 layers or 50 layers, it will be the
It's
same.
ISO 7, class 10,000. It's more than
Sure,
sufficient.
sir. And then a question from Vishal Saraswat. Is mask necessary in clean room environment? The mask is part of the manufacturing process for photolithography. Again,
So you may be telling the mask, wearing the mask.
oh, the face mask.
It's a must. It's a must.
It's a must, yeah.
See, for example, you see, when you go without mask, you may be eliminating a lot of bacteria and virus from the mouth. Apart from that, I'm telling you, when you don't put properly the gowning, the exposed surface of your skin, epidermis, clouds of epidermis coming, which are below 20 microns, you cannot see. That is what, and you're going to touch a wafer. You can imagine how many particles will fall on the wafer. So proper gowning, masking is important.
Rajesh had a follow-up questions with regard to the ESD tiles.
Yeah.
And he asks, how can we clean those tiles? Is it wet mop or are there any other standard solutions?
If you make a wet mop, it is perforated, all the contaminants go on below, the sunken floor below. It becomes also contamination. They're not supposed to mop, you use vacuum cleaners. In fact, you have to suck it.
So dry for that
Yeah,
process.
dry vacuum cleaner.
Next question from Shubhi Tandon. Are there any standards apart from 14644 Part 4 for construction of clean rooms for semiconductors?
They give some guidelines. 1, 2, 3, 4 are there for design some guidelines.
But other than 14644, are there any other standards?
There are for non-semiconductor areas. Okay.
Sure.
For medical applications, pharma applications.
Different standards.
Different, they call it as ABC.
Sure, sir. Then from Ramesh Devani, is clean room setup dependent on AQI, air quality index of region where the fab is set up?
Very good question.
Depend on the AQI of the region.
Important, because normally we will selecting the plant of semiconductors, more important. Very good question. See, normally we try to go very close to the airport. Don't know the reason. Very close to the airport, SEZ areas we want to go. Or should be very close to main road, like national highway. Okay. And the thing is that when you go very close to the airport, lot of contamination of the vibration. Vibration is a noise. Semiconductor manufacturing. Better always go away from the airports. And if you go in the national highway, a lot of trucks, vehicles moving, they have a lot of chemicals, contamination. The air is polluted. Apart from that, if you go very near sea, set up a plant. So there is a saline from the sea is vaporizing. A lot of ammonia, a lot of sodium will be there. So we have to select a proper area where the contaminants are very less. That area is always ideal. I don't know, all the manufacturers want to go to near to the airport, main road. Main road, another problem is it creates a lot of vibration. Your fab. Airports also, the air cutting sound velocity, you know, sometimes your photolithomagnetic performance, suppose it goes above your fab, gives a lot of vibration. Pattern cannot be transported properly. It's a very good question. Is it a proper area where less contaminants are there from outside, both biological as well as chemical?
And vibration also, earthquakes also. I know the Japanese do a lot of study on seismic activity to prevent the earthquake, low probability of earthquakes from the epicenter. The next question is, what is the skill set required for the maintenance of clean rooms?
So that is a very big subject. You see, when you make costly rooms, no, the maintenance protocols are there. So properly, what happens? We train our operators. The scientists do a lot of sensors or fabrication of semiconductors. But we give lost importance to people who maintenance. See, if my heart is a fab, for example, okay, the arteries and veins and the backbone are the things which your maintenance people should do. Without these things, the heart will not work. So properly, you should maintain, train them. For example, I will tell you how to clean the clean room. Basic concept of mopping. Normally, what I observed is they to and fro they reciprocate the mop. So we will be distributing rather than collecting. So there is a figure of 8 should go in one direction. The simple thing I'm just giving an example. Like that, there are so many points are there to train the people to do maintenance, including how to validate the clean room, how to run the air handling system, and how to maintain the positive pressure in the room, how to run the, for example, cold chilled water required for cooling your process tools and gas distribution system maintenance. It's a big subject.
Got it, sir. Thank you. Next question, maybe not a clean room, but more of a physics question. Is relative humidity dependent on outside environment?
Yeah, because in relative humidity inside, normally we say 45% minus 5% or 3%. That depends on the precision of operation and also type of photoresist you use in particularly yellow room. Okay. So as I discussed already, outside it will be about say 82%. We have to achieve 45%. So a lot of process required to control the humidity in the room.
Thank you, sir. Next question from PVG Menon. How is vibration dampening done in a semiconductor fab grade clean room? Vibration dampening.
So I may not be expert in vibration, but recently we did one clean room 30 feet below the ground in Bangalore. So we hired some vibration specialist. Okay. We gone about 10 meters below, and we have the suitable vibration-free foundations in the bottom. And it is isolated from other parts of the site by about 2 to 1, about maybe about 4 to 5 feet width, isolated the whole building itself. And then we have the bottom, there are so many methods of controlling the vibration using different layers. For example, there is a sand, there is a gravel, and then we have a pad, and then different types of layers are there to isolate the fab from other parts of the building. And better to select away from the national highways and the ramps, the railway. There is different method. I'm not expert in vibration, but we are done. It is about 3 microns, I think is controlled. NIST standards at low frequency.
Sure, sir. Next question from VSMK. Sir, can you give a best maintained clean room in the country as an example of a benchmark?
Best still controlled. How I can give.
Maybe SCL or the IISC fab?
I have not visited much. Okay, IIT Guwahati.
IIT Guwahati?
Guwahati, and then IESA, Bangalore, no, CNSE, Bangalore. And one clean room recently we did 10 feet, 30 feet below the ground, Nano Manufacturing Technology Center.
Fantastic. And then the next question from Nilesh Ranpura. How many clean rooms are under construction, installation in India right now? Academic or commercial?
Clean rooms for basically they go for PCBs, frequency drives, and ATMP and OSAT. So recently we finished one clean room for frequency drive and one for making the cardiac stent. There are 4 or 5 clean rooms under consideration for making OSAT and ATMP.
Absolutely. There's so many
And
different.
then some fabs and the process. Particularly one of the public sector near Nimaluru between Vijayawada and Machilipatnam. They got a very big, of course, in terms of we have designed 32 clean rooms are there in that. It is meant for thermal image intensifiers for army jawans. Like that, there are different parts going up.
There must be hundreds actually, if you include pharma, if you include solar,
Pharma is too much.
you include PCB, then you're looking in hundreds.
Solar is very big.
Exactly.
Numbers may be less. Area covered is more in solar.
Huge areas.
Lot of solar, flexible electronics.
Absolutely.
PCB, OSAT. And medical electronics also. A lot of things are coming.
And soon ATMP will be coming. The final and last question, and then we'll wrap up this webinar today. What is the average requirement of pure water in any given fab clean room? And does desalination process help to fulfill the need of the water that is required?
So they are asking what is the clean water required for semiconductors?
Clean room. And then does desalination process help for this water requirement?
See, basically the clean water is nothing but deionized water, which is at 18.2 megaohms at 25 degrees centigrade required for the for etching and then for cleaning the scraping the wafers. So a lot of water is wasted in that in regeneration, like polisher beds. So that is normally treated properly, make pH 7, and then it is recycled. Some water can be used for input water or RO water. Or if it not possible, that water is used to make pH 7 and used for the gardens and flushing the toilets. You also can save a lot of waste of water.
Thank you, sir. We'll conclude today's webinar. I'm getting a few questions about contact details. What we can do is we'll have an IESA email ID that you can send, and then we'll be able to get back with you for more information. There was information about certificates. We'll get back with you on that also. These are all very good. And Mr. Jayadev, again, a very big thank you, and we appreciate your time and the extremely clear and beautiful presentation. I want to thank Mr. Venkata Simhadri, Managing Director of MosChip, and the IESA Manufacturing Core Initiatives Group Chair. And we also wish to thank the Hyderabad IESA chapter for leading this effort. A big thanks to the IESA team in the background who helped put this webinar together. Mushtaq from Hyderabad, thank you so much for the contributions and the fantastic collaboration. With that, we'll conclude today's webinar. Everyone have a happy Ugadi.
Mr. Cole, I thank IESA giving this opportunity, and your team made wonderful arrangements. Okay. And,
Sir, thank you. It's our privilege.
I'd like to do a lot of series like this, including nanoscale technology, what types of cleaning is required, contamination, operation maintenance protocol. There are so many series are there, which itself take 1 hour each. We will discuss with your team and come back in the near future. Thank you very much for this opportunity.
Thank you. Everybody have a good day and happy Ugadi. We look forward to your comments and suggestions. If anyone wants to have suggestions for future Manufacturing Core Initiative Group topics, please email the IESA and we'll take those into considerations. Have a good day, everybody. Bye-bye. Thank you. Bye-bye.